So we go to mode first instead of function. And you might use some of these other ones in the remainder of the course, parametric polar, and then you change it to sequence. And then the most common use is this right here, where we put some function in. This n min is important. That's like whatever index you're starting at. So let's just start at 1. And the third one is actually the like what I thought would be kind of next. It's saying like what is the u1? What is the a sub 1? So let's make it do you think it'll be in the context of a problem we've already done? Like we were doing it was like an interest on a house problem, a payment less interest. Do you remember? Do you think it'll be like that, or will it just be a generic thing?
It'll probably have to do with interest if it comes up.
Okay, so let's do something really simple here. Like you owe someone $100, and that's the first payment. So now the UN is the formula here. So it's the, and this is where I think I have to go alpha 7. Nope.
Okay.
No, it's second 7. Sorry, second 7. U. And then I need to grab the n, which is, where is it on my calculator? They're in alphabetical order. Oh, it's the variable there. So to get n, you have to use the variable there, and we'll just say -1. So it's the previous amount plus the payment that you make. I don't know, let's say you make a $10 payment, but you're getting charged interest on this. So I'll insert like maybe 10% interest, and you're making but let's do it over. Let's divide that by like, I don't know, 12. I mean, you probably get the idea here. And then you subtract out the payment each time. So hopefully this works. The next place to go would be the table. And then you can see here, maybe it didn't really like, I have to make a slight change to this, but the table is where you're probably going to go next. Let me go back to stat plot here, or I'm sorry, y equals. Let me change this. So it's second insert plus, and then it would be a u parentheses n parentheses. So this one takes 10% interest divided by 12 months times the previous amount, adds it to the previous balance, and then subtracts your payment from it. So this should work a little better. No, never mind. It didn't work very well. Oh, I need an n-1 in that. That's why. So you because it's recursive, it's going to be n-1 inside any of the u's. I don't know. Is any of this helpful?
Yep, this is helpful.
Okay. So there's your $100, what you owe. And then first month, you've got some interest and you make a payment. And like, maybe you want to know when this thing hits, when you pay off your debt to whoever it is. Looks like you pay it off somewhere, month 11 or 12. The main thing though, is like being comfortable entering these 3 values. Niko, is there anything there that you saw that you didn't understand or you'd like clarity on?
No, I get it. Yeah.
Okay.
That makes sense.
Okay. There was that WebAssign problem we did on mortgage interest. Maybe try that one again on your own if you got time here. So, Jamie, I see you sent over some stuff. Niko, are you planning to send on anything over?
Yeah, I'm finishing the screenshots to send you.
Okay. All right. So I see 6. I see 1 that does not have a number, but it's eyes, and then log expansion problem. Okay. I'll just start here with 6 and I'll share my screen, which will not be the calculator. It'll be a normal workspace. So let me share my screen and we'll get started here. Okay, where is it? There it is. New share. All right. All right, so find the inverse of f algebraically. The inverse always has a recipe. It doesn't matter whether you're dealing with roots or logs or e's or whatever. The first step is, I don't know if it's even a step, it's y equals f of x. So you, instead of f of x, you write y equals 5 over the square root of x. Second step is to switch x and y.
Oh, yeah.
So you switch them.
Yeah, now I remember this.
Okay. And then x equals 5 over square root of y. And then you, step 3, which is really the big one, is to solve for y. This is the one where you might see the most potential issues. So one of the things you can do is you can literally swap. You can always swap diagonally. You don't have to multiply. The action just moves. You get the square root of y equals 5 over x. And then you square both sides. So y equals 25 over x squared. And then kind of a last step here is y equals f inverse of x. It's just a notational thing. If it's graded by hand, they probably want to see this though.
Okay.
All right, so I see Niko sent over a problem here. Is it 26? Is it all of these or just 11, 26, 27?
I just got signed out of my web design. Hold on 1 second. Let me go back to the email.
Yeah, it's like 26 and 27 came in, and then I can sort of see other pictures here. I don't know, I could probably still do it if you need it.
It should be 26, 27, and then 11. If that picture's not, I'll send another one if you need another picture.
Yeah, so I'm just going to go back and forth, you guys. There doesn't seem to be any sort of like order for this. So I'll jump over here to Niko and we'll look at 26. And Jamie, if you have questions on your 26, you can.
Yeah, let me take a look.
You can ask if there's anything that comes up here. So it's to solve the exponential equation algebraically. That means don't use a calculator. It's actually much better to use a calculator. Do you guys know if you'll be allowed to use a calculator?
Yes.
Yeah. So our final is multiple choice.
Okay.
And then we have calculator for the whole thing.
All right. So I mean, one option, here's option 1, is you put this in y1 and this in y2, and you set, you graph them and you equal that, you figure out where they intersect. That's one option. It depends how comfortable you are graphing with that, because if you can't get your window right, that could be a problem. Option 2, if you have I think it's a TI 84, maybe a CE, I don't know all the models, but it's got like a built-in solver, numerical solver. You guys know about that? I don't know what model calculator you have either. It's kind of the same deal. You put this into y1, this into y2, but it's a box. What make and model calculator you guys? So just a regular TI 84 or CE version?
You're the CE.
Yes, I'm here.
In there. Let me see if I can get you that. So it's math B.
Wait, math what?
B. So it's after 9, 0.
Oh yeah. B. Okay.
Check that out. I'm gonna work this out by hand, so you can see how to do it by hand. But play with that. You'll find it's probably faster than the by hand. Okay. One of the things you really got to be good at though here is rewriting stuff only that you need. So 1.07 to the x equals 275,000, okay, times 0.07 divided by 225. And then the only way to get the x out of the exponent is to use ln. So x equals the natural log of all that stuff that you just did over here. And hopefully you guys can enter all this into your calculator in one step. Save you a ton of time by doing this. Wow, can't copy anything. Copy. Paste. Okay, that wasn't any faster. And then you divide by the natural log of 1.07. But any luck playing with that math B that did anything?
I'm trying it right now.
You may try it with something simpler, like y equals x plus 1, y equals minus x plus 1. And like seeing if you can get something like that to give you the nice, figure out how to make that work into something nice. The solution to that is 0, 1 for this thing. Okay, so we're going to jump back to Jamie. You sent, we'll just go back and forth here. You sent this one with all the I's. All right, so the i's repeat. So I to the 1 is the square root of -1. I squared is -1. I cubed is -I. And then I to the 4th is +1. And then these repeat, okay? So you have to take this exponent and divide it by 4 and see if there's a remainder. So this is a remainder of 0. This is a remainder of 1, remainder of 2, and a remainder of 3. So there's no remainder for that one. So I to the 44th is just 1. Now the divisibility rule for 4 is you just look at the last 2 digits. So you don't care what that first one is, but let's just think about that for a moment. If that's 100, is 100 divided by 4? Yes, but you don't actually care. You just care about these two right here. When you divide it by 4, you get a remainder of 2. So that's -1. 74 here divided by 4. What do we got here? So that's remainder of 2, I think, on that one. So it ends up being minus a -1. 109 is a remainder of 1. So that's I. This is minus I. 69 is also, no, 69 is remainder of 3. So it's plus -I. So those cancel. And we have 1 minus 1. This is +1. So I think it just equals 1. So I would say false on that.
Okay.
And if you get more than one guess, like maybe in a college class, you should just maybe just consider just checking one and moving on. Save some time on that.
Yeah.
All right. So Niko, your questions, like I can see 27 and I see that you sent 11 and maybe something else. I mean, I can snip it in, but something weird happened on my side on the email. But I'll do 11 next.
Yeah, that's fine.
And you can tell me if there's more to this. All right, consider the following. So long division here. Yeah, I mean, it depends what you're being asked. Like if you're being asked to actually write the polynomial, you would divide. If you're asked for the other roots, you might just graph this and find the roots that way. Do we actually want to do long division or synthetic division? Okay.
Synthetic works. But you said, can you clarify on the calculator? Just you can find the zeros.
Yeah, yeah. So this graph, I mean, I don't know what it looks like, but it probably hits 3 times, and you just find the 3 zeros. And maybe the question is asking you to like write it in factored form. So you just get those zeros, and let's say it's x minus 3, x plus 1, x minus 2. I mean, that's probably what they're looking for here.
Okay.
Just be careful that you actually can see them. Your window's nice. Synthetic division here won't take much effort though. You have to write the coefficients, and you need all of them. Meaning, like if there wasn't an x to the 1 here, you would still have to include a 0 coefficient for any missing term. That first number comes down, then you multiply. You're always adding vertically. And then you, oh, well, this one actually doesn't work. So I take that back. -60. This is -48. So this is your remainder. And the way you write your solution here, it's quotient plus remainder over divisor.
Okay. So then I just write it as x squared minus x minus 20, and then the remainder over.
Yeah, minus 48 over x minus 3.
Okay, thank you.
All right, so let's jump back to Jamie. Let's see here. This got this expanding logarithm thing here.
Yep.
Right. Assume all variables are positive. Okay, so the like the first step here is a rewrite step. You have to remember that the square root of x means x to the 1/2. So in this case, it's the natural log of x squared over y cubed all to the 1/2 power. That's your first step here. And then we're gonna use the exponent property of logarithms. So if I give you log base b of x to the n, this n can come out in front, n log base b of x. So that 1/2 comes out in front, 1/2 natural log x squared over y cubed. And then the next property here is that a quotient or division becomes subtraction. So if you have log base b of like a over b, it becomes log base b of a minus log base b of b. So this becomes 1/2 natural log x squared minus 1/2 natural log of y cubed. So if there's a coefficient in front, you have to give it to both of these. That's why the 1/2 goes to both. And then at this step, you apply this exponent property. Again, this 2 comes out in front, this 3 comes out in front, and they're multiplying. So it's 1/2 times 2, but that just becomes the natural log of x, because 2 times 1/2 is 1, minus 3/2 natural log of y. All right, so Niko, I'm gonna look at your, you got kind of a solve a logarithmic question here, 27. Look at that
Yes.
next. I guess that's somewhat related to what we just did here. All right, so solve the logarithmic equation algebraically. Again, you could put this left side into y1, the right side into y2, figure out where the graphs are equal. You could use that numerical solver. If you actually want to do it by hand, you have to do the log. You have to get the log of something equals a number. So on the left here, we have to use that property I just said. It's undoing it. It's the log of a minus the log of b becomes the log of a over b. So it's this quotient to difference property in reverse. So you write log 4x over 9 plus square root of x equals 2. Now, whenever the log base is not written, there's really a 10 here. Okay, and you undo log with 10. Like this is the official, like here's how you do it to impress your math instructor or professor, to undo logs. You write 10 to the log, 10 to the 2. You have to do it to both sides. If you don't, it becomes invalid. So on the left, it just undoes this. It's 4x plus 9 plus square root of x equals 100. From here, you guys probably know how to solve this. You get 4x equals 900 plus 100 square root of x. And this is horrible now. Yeah, I mean, like we can keep going here, and I don't mind doing that, but I guess I'm going to go back and focus on the fact that it does say to approximate to 3 decimal places. Like whenever I see stuff like that, that's when I go to a graph, because I'm like, oh, the answer doesn't really matter. They just want a decimal approximation. So to do this right, you would square, where I'm going to move the 4x minus 900 equals 100 square root of x. You square both sides. So on the left here, you get 16x squared. Let's see here, 36 minus 7200 x plus 81, 4 zeros, 810,000 equals 100 times 100, 2, 3, 4, x. Okay. And then you move this over, and then you either factor or use quadratic formula. So I guess I would tell you, like, at some point you should have said, hey, there's too much effort here. Let me just go and graph it.
Okay.
If you need the answer, I can use a graph real quick to get this if you're looking for that specifically.
I have a question. In the graph, would I subtract a 2 over, or do I just
No,
or do I just do y equals 2?
I like y1 and then y2.
Okay.
And then find the equal of them. It also kind of helps you to know that the graph has to go to 2 on the y. Like you know, this log thing, I don't know what it does, but let's just say it does that. You know, it helps you to figure out the window for that.
Okay.
I am going to get you the answer at least. I'll feel like it's reasonable to do here. Wow, you got to go way out on that. All right, so the answer is 1025.641 is what I get for that.
Yeah, that works. Thank you.
All right, we're back to Jamie. We've done those first 3 you sent. I see you sent another picture here, 32.
Yep.
All right, so I remember us doing this. We're definitely going to set this up and then probably use the calculator, use the matrix and then the reduced row echelon form for this. Let me get this. So the nice thing about WebAssign is it tells you the variables by telling you, like, you need to find C, M, B, and G.
Yeah.
Okay. So we got to come up with some equations here. So an investment of 520,000, so that's C plus M plus B plus G equals 520,000. So one to go. Okay. All right. So certificates of deposit pay 9% annually. Municipal bonds pay 4% annually. Over 5-year period, the investor expects the blue chip stocks to return 12%. What's to the right of that?
Oh,
and the growth stocks and the growth stocks return. Okay, so there's just this. Okay, so the investor wants a combined annual return of 10%. Okay. So the next equation is 0.09 times C. Is that the first one? No. Yes. Plus 0.04M plus 0.12B plus 0.14G equals 52,000 because they want 10% return. So 10% of 520,000 is that.
Mm-hmm. Okay.
All right. Now they want only 1/4 of the portfolio invested in stocks. So which are the stocks? So that's B and G. So they want B plus G to equal 1/4 of the 520,000. And this is where, you know, you maybe got stuck, maybe not. But this means that 3/4 of it has to be invested in the other stuff. The C plus M.
Mm-hmm. Got it.
Okay, so this should give you enough to solve it. I'm going to use, so you want to get that in your calculator. You want to use reduced row echelon form after you get it in. Most of the mistakes are made entering the data. So just take the time to check it. Sorry, there's a C there. Two, 4. And your calculator can do the point or the 1/4 of like 520,000 when you're entering it in. You can actually just type in the calculation and it'll do it for you.
Oh. Okay.
Ooh, okay. So I wonder if I made a mistake here. Oh yeah, so you should get an entire row of zeros when you do this.
Yeah.
And that tells us, okay, we have to do something about this. So I think it even says here, if it says if the system is dependent, set G equal to S and solve for C, M, and B in terms of S. So your final calculation looks something like this. Like maybe you have 0.4 or minus 0.4 instead of that. So the third row, here's what the third row means. It means that B plus G equals 130,000. And they're telling you make G S. Okay, so that's S there. So if G is S, then B is 130,000 minus G,
SS?
which 130,000 minus S, yes. Okay, and then the second row tells you that, what's our next variable? M plus minus 0.4 G equals minus 26,000. So you just move it over. M equals 0.4 G, but it's really S minus 26,000. And then similarly for the last one, it's 416,000 minus 0.4 G or 0.4 S.
Got it. Okay.
All right, Niko, do you have? I've gone through everything you've sent me. Do you have some others that you'd like us to look at together?
Yeah, just been writing in notes for all these problems.
Sure. And if you have different numbers, we could look at them too together.
I just sent over another one.
Okay, we'll take a look. Oh yeah, actually you did send me one more I didn't do in the previous grouping. Is that maybe the same one? Yeah, okay,
So.
that's a better picture. Are you using a Mac by any chance?
No, I'm using a Windows computer.
Windows computer, okay. All right, so let's look at this one. Use the leading coefficient test to describe the right hand and left hand behaviors. They basically want to know like what happens to this graph. So you look at the highest power there, and a cube either does this. It either starts low and ends high, or it starts high and ends low. This negative out in front is if the leading term is less than 0, and this is if the leading coefficient is greater than 0. So you know that it falls to the right and rises to the left. And these are for odd. This is the odd power. So for even powers, it's kind of similar. If the leading coefficient is positive, it starts high and ends high. If the leading coefficient is negative, it starts low and ends low. And these are for even powers. Definitely something you want to remember. You could also just graph this, Niko, if you were like really stuck and didn't want to remember all this stuff. You just enter this in your calculator and like see which way it looked.
Okay.
All right, so Jamie, you sent over, yeah. So I'm through, Jamie, with everything that you sent me, I believe. You can correct me if I'm wrong.
Find, see if I have anything else.
Yeah.
Can I send you over a couple more?
Of course, yeah. We got plenty of time here. Encourage you both of you to send over what you want here.
Okay, I just sent you some over.
All right, let's take a look. Okay, 22, and then I see a 25 problem. Okay, great. Yeah, Jamie, if you got any, could be a great time to send them over. So let's start with all right, let me snip this in. All right, find the interval of the domain. So the domain is based on what's inside the parentheses here. You set that greater than 0, not greater than or equal to 0. And that's related to this next part. The equation of the vertical asymptote is where x plus 3 equals 0. It doesn't matter what the base is, it's just whatever's in parentheses. So the equation of the vertical asymptote is x equals -3, and then the domain is x greater than -3. So just convert that to this form here, interval notation. The x-intercept is obviously where it crosses the y. I'm sorry, the x-axis, which is where y equals 0, or in this case, f of x equals 0. So you set y equal to 0. 0 equals 8 plus log base 8 of x plus 3. And you can solve it sort of directly. They want you to round your answer again to 3 decimal places. You kind of know, like, oh, this isn't gonna work out great, although yeah, it's not great. So you subtract 8 from both sides, log base 8 of x plus 3. To undo the log over here, it's 8 to the log base 8 of x plus 3, 8 to the -8. That gives you kind of that small exponent here. On the right, it just becomes the x plus 3. So your x is 8 to the -8 plus 3. 8 to the -8, it's got to be so. I mean, I'm guessing it's 3.00. No, I'm sorry, -3. Subtract 3 there. It's got to be really close to -3. All right, so Jamie sent over something here, 28, is that right?
Yep.
Okay. All right, the sales S in thousands of units. Okay, so like that's really important. That means that this 2,800 units is really 2.8. units. Like gotta be careful
Oh,
with
yeah,
that,
yeah.
because the other one will, like, it still kind of works, but you get unreasonable dollars, X $100. So again, like if it's 2, if X is 2, that's 200. You gotta kind of notice that stuff like there. So this first part just wants you to find the value of K. So they're giving you X 100. So this is really 6. S is 2.8. So this is X. This is S. 2.8 equals 10. 1 minus E to the K times 6 power. And, again, you could graph this. You could use that math B solver, or you could do it directly. 2.8 divided by 10 equals 1 minus E to the 6K. We'll change like that. So 2.8, that's divided by 10, that's 0.28. And then you can move it over, you can subtract and add, and you get E to the 6K equals 0.72. ln gets the variable out, so it's ln of 0.72. And then K is equal to natural log of 0.72 divided by 6. Always better if you can go to that last step before entering into your calculator, and that way there's no rounding errors. I really wish I could find my cursor so that I could get the calculator going. All right, there it is. So we got log of 0.72 divided by 6. So I get negative 0.0548. That's only part A though. Part B, you have to use your result from K. So your equation is S equals 10. 1 minus E to the minus 0.0548x. And they want to know if you can spend $850. So 850 is 8.5 for X, because it's in hundreds. So you put that number in there.
Okay.
And you got to be careful here, because your answer, whatever it is, you have to multiply by 1,000 times 1,000. So try to run through these numbers here. So there's nothing inherently difficult about this. It's that these unit conversions can really mess things up here. So I get 3.7237, but then you have to multiply that number by 1,000. So it's always better if you can do that in your calculator, like keep that last value in there and then multiply by 1,000. So I get 3.724 units.
Got it.
All right, let's jump back to Niko. Some sort of horrible log, another log one here. Okay, so this is kind of similar. Here, okay. So some of this is like setting t equal to a certain value. Some of it's setting the f of t equal to some sort of value. So let me see here what the variables are. Month for the year. Okay. Does it tell you? So t is in months. Is that right? T is the number of months.
I think so.
And f of t is the score.
Oh no, t is time. Yeah, t is time in months, and then f of t is
the score, I'm guessing.
Yeah. Yes.
Okay, so what was the average score in the original exam? T equals 0. So they're saying put 0 into here. So it's 90 minus 15 log base 10 of 0 plus 1. This ends up equaling 90. Part C is to do it with t equals 6. So that's 90 minus 15 log base 10, 6 plus 1. Log 10, 7. Okay, So I get 77.3 for that. So it goes down. What was the average after 12 months? Okay, so same thing. You said t equal to 12, 90 minus 15, log base 10, 12 plus 1. So it gets 73.3. And on the last one's perhaps the most difficult. Now they're giving you f of t equals 81. So you're saying 81 equals 90 minus 15 log base 10 of t plus 1. So you have a choice again. You can either, you know, y1, y2. You can solve it directly. You can use that solver. So if you subtract 90 from both sides, you get minus 9 equals minus 15 log base 10 of t plus 1. Divide by minus 15. That gives you 3/5 equals log base 10 of t plus 1. You undo log with 10. 10 to the 3/5 equals t plus 1. So t is 10 to the 3/5 power of 0.6 minus 1. 2.9, oh, it's 3.0. Anything else for tonight, guys?
I think that's everything I have.
Would encourage you guys to, Niko, if you want to find something, I've still got a few minutes, but I encourage you to do as much as you can on your own. Obviously, you guys are good math students, but the more you try, the more it becomes familiar, and math does get harder. Even if this seems easy, it does get harder. So the skills you're building here actually do matter in future math classes. So we've got a session tomorrow, so just come ready. If you don't have anything else for tonight, just, you know, we'll get through whatever else you guys want to look at, but I'll wait on you. Is there anything else you guys would like to look at tonight?
I think I'm okay. Thank you.
Jamie, you okay? All right. Well, thanks so much, guys. I'll see you tomorrow. Have a great night.
See you tomorrow. You too.
Okay, bye now.